Hello everyone, and in this video, we continue to talk about complex elements within the JavaScript language in simple terms. Specifically in this video, we will talk about two operators that appeared in the ES6 syntax, which are rest and spread. We will discuss why they are needed and where they are applied. To save some time, I have prepared two arrays, one that contains Siberian cities and another that contains European cities. Plus, there are two objects here, but we will talk about them a little later. To start, let's understand the spread operator. Why is it needed and what does it do? And actually, if we log to the console, let's say the first array, for example, cities Russia, then I think we will get the expected result. We see that in a console we get an array of 4 elements, where each element is a string. This means we can expand it, and each of these elements is accessible by index. What does spread have to do with it, you might ask? The fact is that this operator is just 3 dots, and it is generally written like this. If we apply the spread operator to the cities Russia array, let's look at the result, and the result we get in the console is as follows. So, as you can see, we are no longer getting an array here, we are just getting a set of strings. So, in essence, that's all the theory regarding spread. It essentially cakes and expands the array we are working with. That is, by analogy, we can expand the cities Europe array. Yes, and we do not get an array, but we simply get different strings. You might ask me, why do we even need this and what practical applications does this operator have? In reality, there are many of them, so let's look at the basics. For example, let's say I create an array called all cities, and this will be my array. And for example, if I want to clone, say, an array that contains Russian cities, I can simply take and spread the array that I want to clone. And now, if we look at what all cities is, we will see that it is a basic array that is exactly the same as cities Russia, but in fact it is already different. Yes, meaning it has a different reference. We cloned it because here we created a new array using square brackets, and then inside we spread all the elements that were in the array. What's cool is that now we can, for example, merge different arrays this way. Let's say we can also spread another array here, cities Europe. Refresh the page, and we get a merged array that includes, in general, all the cities. What's also great about the spread operator is that it easily combines with other elements. Let's say, between the cities Russia and the cities Europe, I want to place some city. For example, let's say Washington. So, this syntax is also possible, and in this way, using the spread operator, we can very easily combine different elements to form future arrays. As you can see, it is all very flexible. Moreover, if we, for instance, swap cities Europe and cities Russia, then, accordingly, this order will also change in the resulting array. Let's say I remove Washington. For comparison, to see how this works with arrays and how it was done before, we could use the concat method. That is, we get a new variable all cities, n. Then, for example, if we want to maintain the same order, we call the concat method on the cities Europe array, which allows it to merge with another array and produce a new array as the output. And here we pass cities Russia. So, previously it looked like this, but with the spread operator, it's more visually clear, I think. If we refresh the page, we get this result. So, for arrays, this is all the theory you need to remember. When this operator is applied to an array, it essentially takes and spreads out all its elements, effectively removing the array itself. But the spread operator is more powerful because it allows us to work with objects as well. And now we can take a look at the objects that I have prepared. Specifically, this is a regular cities Russiaway population object, where we see the names of some Russian cities in a very arbitrary figure, which I came up with, representing the population in millions of people. I did not verify this information, and any number could be here. The same applies to European cities, for Berlin, for Prague, and for Paris. In other words, in the end, these are just regular objects where the key is a string representing the city name and the value is simply a number. And now let's see how the spread operator works with objects. That is, the same operator, but not with arrays, but with objects. And to start, let's try the following. First, let's try to output this object to the console. The first one, while we work with the first one. And as expected, we get the object itself in the console. But if, for example, we apply the spread operator to it and pass the page, then we get an error here, stating that a non-callable iterator was found. Why does this error occur here at all? For the simple reason that when we work with objects, such syntax is not possible. The idea of the spread operator is exactly the same here. It is applied to an object and expands all its keys. It's Moscow, St. Petersburg, Kazan, Pittsburgh, Kazan, etc. However, if we apply this to arrays, we simply get a set of scattered strings, whereas when applying this to an object, we don't really have a place to store these keys. And when working with objects, we need to put all of this into other objects as well, meaning we need to wrap it in curly braces. If we leave it like this and refresh the page, we ultimately get an object. So, what exactly happened here? We created a new object using curly braces, and then, by applying the spread operator, we expanded the values of all the keys in this object, and as a result, created a new object. In other words, here we use the spread operator to clone the object and create a new one. This is one of the main applications of the spread operator for objects, and let's see how it works. So, for example, I want to create a new object. That is, I create it here using curly braces. And, for example, I meet an object cities, Russia with population, and then I want to concatenate this object with another object. That is, to create in the end one object consisting of two. And here I can also apply the spread operator to another object, which is cities Europe with population. That is, you might have encountered similar syntax in some frameworks, particularly in React, and now also in Vue. And essentially, it just means that we are creating one common object consisting of these two objects. And in the end, we get one object that contains all the other keys. That is, the spread operator expands these keys and places everything into a new object. What's interesting here? It's that indeed a smart merge is happening. Merge is the process of combining objects, not just objects, but in this case, it is objects. What do I mean? Suppose in the cities Europe object, we can also include, say, the key for Moscow. Well, for example, according to Europeans, there will be 26 million people here. So, the situation here is that this object has the key Moscow, and this object also has the key Moscow. The question arises, which key will end up in the resulting object? And I think it's obvious here, since the cities Europe object comes last, its key will be applied. So, in the end, we should see 26 million here. We look, and indeed, here we get the number 26. That is, this number 20 is kind of ignored and replaced. Similarly, if we change the order. In the first object, we get 26 million. In the second object, we get 20. Yes, because initially, the key with the value 26 is applied, but then we add this value with the number 20. So, the order also matters here. Now let's look at some practical and real-world applications of this operator. I will write a comment. Practice. Suppose we want to find the maximum number. Using the math object and its max function with the following values, let's say 5, 37, 42, and 17. This is exactly how parameters are passed to the max function. Let's take a look at this in the console. I will refresh the page. And obviously, we get 42 because it is the largest number among those provided. We see how we pass parameters to this function here, but usually we have some array of elements. Let me create an array. I'll call it numbers, and then proceed to create it from these elements. That is, usually we don't even know how many elements are in the array, and we need to find out which number is the maximum. But if we try to pass an array to the math.max function, it is already clear how the function complains about the incorrect type passed to it. If we return the page, we get none here because it tries to find the max as if using an array. And this is the moment when the spread operator can come to our aid. Yes, so I will comment out the first call. The function does not accept an array, but if we spread these values, we will get exactly the same result. Yes, and in the output, we see that we get 42, meaning our function works successfully. By the way, just for interest, this is how it worked before the spread operator existed. We worked with the math object, accessing the function we want to call, such as max, min, or others. But instead of calling it, we used the built-in apply method. The context is not important here. And as the second parameter, the apply method takes an array of arguments that need to be passed when calling the max function in this case. This is numbers, and this is how it will work. So, we still get 42. I discussed the methods call, bind, and apply in more detail in a separate video in this playlist. There will be a hint now, so you can check it out. Okay, this is the first use of the spread operator. What else can we do? Suppose in the HTML that runs this script, I add a few divs. Let's say there are 4 divs, and there are usually situations where we need to access specific DOM nodes. So how do we do this? Let's say I create a variable called divs and access it using the document.querySelectorAll function, and then I will have access to all the divs. Now let's take a look at what the divs element is. If I refresh the page, I get something like an array here, but we can clearly see that this is our note list. If we look at what note list, the prototype is, it is not exactly what an array is. Well, for example, what problems could there be here? Let's say, if we call the forEach method, everything is fine, because it is defined in the prototype. However, if we, for example, want to call the map method, the map method is not available here. If I refresh the page, you can see that gifs map is not a function. This is simply because it is not an array, but a collection of DOM elements. Often, we want to get an array, for example, to use the map method. Therefore, the spread operator can come to our aid here. Let's say I call all of this nodes. And if we apply the spread operator to this pseudo-array divs, then let's see what we have. Nodes. Here we see that this is already an array. That is, the same idea, but now the prototype contains all the elements and methods characteristic of arrays. Including somewhere here is the map method. That is, you can make sure that if you call this method, everything will work. Accordingly, we can look at the divs again and, for example, ask. Using the raisArray method to check if the given element is an array and if the object nodes is an array. In the first case, we get false, and in the second case, we get true. However, we get true because we use the spread operator to convert the given node list into an array, which is also a very common application that you can use in practice. Okay, now let's discuss another operator that is very similar to the spread operator, but still different, and it is called rest. That is, the rest operator has exactly the same syntax as the spread operator. The only difference is in its area of application. And for example, let's try to break it down. I'll collapse it to make it a bit easier to read everything. By the way, you can find the code later in the description of this video in a gist on GitHub. As an example, I will create a simple function called sum. This function will add two elements, a and b. So, basically, at the output, we return their sum, a plus b. And let's assume we have an array called numbers, where elements 1, 2, 3, 4, 5 are stored, and that should be enough. Now, let's say I want to print the result of the sum function in console log. We see that it takes two parameters. I want to sum the elements of this array. And this is exactly where we can also use the spread operator, because this function does not take an array, but rather takes individual arguments. But if we apply the spread operator here, and this is important, here it works as spread. So let's see what we end up with. I refresh the page and we get 3 here. Why do we get 3 here? Simply because by writing it this way, and I repeat that this is the spread operator here, we break down each element of this array into 5 arguments, and the sum function kind of takes 5 values here. But here we are only processing 2 values, and therefore we get the sum of 1 and 2, which gives us 3 as the result. That is, the remaining arguments, these ones, are kind of ignored by us simply because we don't see them. And in fact, in JavaScript, we can handle them without explicitly describing them. For example, in the past, we could use, and in principle, we can still use an object called arguments. But here the REST operator can come to our aid, which is essentially used in this way, meaning 3 dots are placed. But in this case, it is the REST operator because it gathers the remaining arguments into a new array. Well, let's just call it REST. Now, if we look at what REST is, and here I am naturally referring to this variable just as a variable, without any dots, we see that it is simply a regular array. That is, the REST operator in this case took and gathered all the remaining parameters into this array. Interestingly, if I remove all arguments from the function and refresh the page, I get an array of all the arguments that were passed to me. By the way, if I write 3 dots here, let's save it. Here, I am already getting the individual elements, but in this case, it is the spread operator. I showed this just for, probably, a very thorough reinforcement. Let's revert everything back to how it was and now try to work with this array to accomplish our task. That is, here we have gathered all the remaining arguments that come into our function. And let's say we also want to sum all the elements. We can easily do this using a method built into arrays. That is, I am referring to the array itself, and the method is called reduce. I have also talked about it separately, but it is very simple in that the first parameter it takes is a function, and the second parameter it takes is the initial value of the accumulator. That is, we want to sum all of this from 0. Here is the accumulator, the iterated element, and all we do in the reduce function is sum all the remaining elements. So, in this case, when we refresh the page, we get 15. And indeed, if you manually calculate the sum of these elements, it will be 15. If we add, say, 6, 7, and 8 here, we don't change the sum function, but the result changes. This way, we process the incoming parameters. Now let's look at another area of application for the REST operator. We already have an array called numbers, and let's assume we need to extract some values from this array. For example, I want to assign the value of numbers at index 0. To variable a, the value of numbers at index 1. To variable b, and so on. So, if we look at a and b, it is obvious that we will get 1 and 2 in ES6. Syntax: if there is a shorter notation for such an action, it can be documented. It looks like this, meaning we kind of take individual values from the numbers array into variables a and b, and this is called destructuring, about which I will record a separate video. Most likely it will be the next one in the playlist. But this notation is completely identical to what is written above. That is, if we refresh the page, we get the same values. Yes, we get A and B respectively by their indexes from the members array. But in this case, let's say, if we want to get all the remaining values in this array, we can also use the rest operator and say that, for example, all the remaining values except for the first and second elements in the array will be in the variable ATA. If we look at it, we get the rest of the array, and this is also where the rest operator is applied. Similarly, the same situation applies to objects. For example, let's say I create an object person. It will have a name Max, and let's say the age will be 20. Well, for example, it will have the parameters city Moscow and, for instance, country Russia. Here we can also apply destructuring, which for objects looks like using curly braces. And here we get, let's say, a separate variable name and a separate variable age. Yes, I think it's obvious that if we log them to the console, we will get the corresponding separate variables, if, of course, all this is preserved. Yes, Max and 20, but here we can also use the rest operator and collect, for example, all the other values that are in the object into a new object. So it looks like this. Let's say in the variable address, if we look at the address, we get a separate object here that has the value city and country, which is also logical in principle. So that's really all there is to the spread and rest operators. It's important to remember that they only differ in their area of application. Spread essentially expands arrays or objects and is mainly used for creating new arrays or new objects, or to transform them into more convenient data types. The rest operator, it kind of gathers all the parameters either into an array, which is often seen in functions, or into objects, all the remaining fields. With that, we will end this video. If you find this content interesting, I would appreciate it if you support this video with a comment, like, bell, subscription to the channel, and more, and we will see each other in other videos.